9.5 goes over solving equations using your quadratic formula. Your quadratic formula you might have seen before. It is just x is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a, where a cannot equal 0 and b squared minus 4 times a times c has to be greater than or equal to 0. Remember, you cannot take square roots of negative numbers. So that's why that inside, underneath that square root, has to be something that's equal to a number greater than or equal to 0. For each of these, we want to start by identifying our a, our b, and our c term. If we look at this trinomial that they give us on how we get this x is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a, or 2 times a. We're using the a, the b, and the c from that trinomial. So your a is your coefficient of the x squared, your b is the coefficient of x, and your c is your constant. So what I would do with all of these is I would identify your a, your b, and your c to begin with. For example 1, we're just solving each of these equations using the quadratic formula. For a, we're given 2x squared minus 5x plus 3 is equal to 0. So our a is 2, our b is negative 5, and our c is 3. You'll realize that the sign that's in front of each of these terms I keep with the term. So we're going to plug this into our quadratic formula, which is just negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So plugging these values in, we have x is equal to the opposite of negative 5 plus or minus the square root of negative 5 squared minus 4 times 2 times 3 all over 2 times 2. The opposite of negative 5 is 5. Put that plus or minus, then the square root, that negative 5 squared is 25. Minus 4 times 2 is 8, times 3 is 24. So that's minus 24 all over 2 times 2, which is 4. From here, we're going to simplify underneath the radical. So this is going to give us x is equal to 5 plus or minus the square root of 1 all over 4. The square root of 1 is 1, so that gives us x is equal to 5 plus or minus 1 over 4. From here, you'll realize that we have to separate this into two parts. One that is x is equal to 5 minus 1 over 4, and one that's x is equal to 5 plus 1 over 4, and simplify. From here, the 5 minus 1 gives us 4 over 4, which is just 1. And then the 5 plus 1 gives us 6 over 4, which is x is equal to 3 over 2. So your two solutions here are 1 and 3 over 2. For example B, we're given x squared minus 6x plus 5 is equal to 0. Now you could solve this one by factoring it, because the factors of 5 that add up to be negative 6 are negative 1 and negative 5. However, keep that in mind while you're working on this. You should be getting the same exact answer just using your quadratic formula. So it's just another way of solving it. Your a here is 1, b is negative 6, and c is 5. Use your quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Plug everything in. So we're going to have the opposite of negative 6 plus or minus the square root of negative 6 squared minus 4 times 1 times 5 all over 2 times 1. From here, the opposite of negative 6 turns it into a positive 6. Plus or minus the square root of negative 6 squared is 36. Negative 4 times 1 is negative 4. Times 5 is 20. All over 2 times 1, which is 2. The 36 minus 20 underneath the radical is going to give us 6 plus or minus the square root of 16 over 2. The The square root of 16 is 4, so x is equal to 6 plus or minus 4 over 2. Since that radical simplified to be a whole number, we're going to separate this into two parts. So we're going to have x is equal to 6 minus 4 over 2, as well as x is equal to 6 plus 4 over 2. From here, 6 minus 4 gives us 2 over 2. 6 plus 4 gives us 10 over 2. So x is going to be 1 and x is going to be 5. For example C, we have 1/2 x squared plus x minus 10 is equal to 0. I'm going to identify my a, my b, and my c first. So a is 1/2, b is 1, and c is negative 10. Again, I'm going to use the quadratic formula, so x is equal to negative b plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. B is 1, so that's going to give us x is equal to negative 1 plus or minus the square root of 1 squared minus 4 times a, which is 1/2, times c, which is negative 10, all over 2 times a, which is 1/2. This is going to simplify to give us x is equal to negative 1 plus or minus the square root of 1 squared is 1. Negative 4 times 1/2 is negative 2. Negative 2 times negative 10 is a positive 20. All over 2 times 1/2, which is 1. Anything over 1 is itself. So 1 plus 20 underneath the radical is just giving us x is equal to negative 1 plus or minus the square root of 21. This again would be over 1, so you could just leave it as the x is equal to negative 1 plus or minus the square root of 21. For example D, we have negative 3x squared plus 2x plus 7 is equal to 0. So if I identify my a, my b, and my c, my a is going to be negative 3, b is going to be 2, and c is 7. Again, I'm plugging this into our quadratic formula, which is negative b plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. So plugging these values in, we have negative 2 plus or minus the square root of 2 squared minus 4 times negative 3 times 7, all over 2 times negative 3. From here, simplify what's underneath the radical. That 2 squared, negative 2 plus or minus 2 squared is 4. The negative 4 times the negative 3 is a positive 12. 12 times 7 gives us a positive 84. And then 2 times negative 3 is negative 6. So this simplifies to be negative 2 plus or minus the square root of 88, all over negative 6. From here, that 88 is 8 and 11. 8 is 2 and 4. 4 is 2 and 2. We're doing the square root, so a set of 2. This is going to simplify to be x is equal to negative 2 plus or minus 2 square root 2 times 11, which is 22, all over negative 6. Now, when you simplify this, the sign matters. That 6 in the denominator should be positive. So when you change this, it's going to change the sign of the terms up top. Now the plus or minus 2 square root 22 is not going to change because that plus or minus is in front of it, so it carries both signs. So you don't have to worry about that. However, the 2, 2, and 6 are all divisible by 2. So we're going to simplify those as well. This 2 becomes a 1, this 2 becomes a 1, this 6 becomes a 3. So we're going to have x is equal to 1 plus or minus the square root of 22 all over 3. For example E, we're given 4x squared minus 4x is equal to negative 1. All of our terms on this one are not on the same side, so we want to move that negative 1 over to begin with So we're going to add it to both sides. This leaves us with 4x squared minus 4x plus 1 is equal to 0. This gives us an a of 4, a b of negative 4, and a c of 1. Using our quadratic formula, which is negative b plus or minus the square root of b squared minus 4 times a times c, all over 2 times a, we're going to have x is equal to the opposite of negative 4 plus or minus the square root of negative 4 squared minus 4 times 1 all over 2 times 4. From here, we're going to have a positive 4 plus or minus the square root of 16 minus 16 all over 8. This square root of 16 minus 16 is the square root of 0. The square root of 0 is 0. Four plus 0, 4 minus 0 is still just 4. So this is just going to leave us with one solution of 4 over 8, which simplifies to be 1/2. So if that radical simplifies to just be 0, then you're only going to have one solution. For our next part, we are going to be determining the number of solutions of the equation. With this, we are going to use the discriminant. The discriminant is just the part underneath the radical in your quadratic formula, so that b squared minus 4 times a times c. If you use that and you get an answer that's greater than 0, you have two solutions. If you get 0, then you have one solution. And if you get a number less than 0, so a negative number, you have no real solutions. So, with these, for example A, we're given x squared plus 8x minus 3 is equal to 0. All of our terms are on the same side of that equal sign, so we're good to identify our A, our B, and our C. For this one, our A is 1, our B is 8, and our C is negative 3. Our discriminant is just b squared minus 4 times a times c. So plug your values in. You're going to have 8 squared minus 4 times 1 times negative 3. The 8 squared is 64. Negative 4 times 1 is negative 4. Times negative 3 is a positive 12. We add these and we get 76. 76 is greater than 0, so we have two real solutions. For example, B, we have 9x squared plus 1 is equal to 6x. Again, we want all of our terms on the same side of this equal sign. That 6x does need to move over, so we're going to subtract it from each side. This leaves us with 9x squared minus 6x plus 1 is equal to 0. Our A is 9, the B is negative 6, and our C is 1. Our discriminant is b squared minus 4 times a times c. So we plug these values in. It's going to be negative 6 squared minus 4 times 9 times 1. The negative 6 squared is 36. Negative 4 times 9 is negative 36. Times 1 is negative 36. 36 minus 36 is 0. 0 is equal to 0. So we have one real solution. For example, C, we have negative x squared plus 4x minus 4 is equal to 0. All of our terms are on the same side, so identify your A, your B, and your C. A is negative 1, B is 4, C is negative 4. Use your discriminant, which is b squared minus 4 times a times c. This gives us 4 squared minus 4 times negative 1 times negative 4. 4 squared is 16. Negative 4 times negative 1 is a positive 4. 4 times negative 4 is a negative 16. So 16 minus 16 gives us 0. 0 is equal to 0. So we have one real solution. For example, D, we have 6x squared plus 2x is equal to negative 1. We're going to move that 1 over by adding it to both sides to begin with. So this gives us 6x squared plus 2x plus 1 is equal to 0. Our A is 6, B is 2, C is 1. Plug this into B squared minus 4 times A times C. So this gives us 2 squared minus 4 times 6 times 1. 2 squared is 4. Negative 4 times 6 is negative 24. Times 1 is negative 24. 4 minus 24 gives us negative 20. Negative 20 is less than 0. So we have no real solutions here. So when you look at all of these, what you're seeing with these 2 real solutions, 1 real solution, or no real solutions is how many x-intercepts you have in the function for these quadratic functions, or on the coordinate plane for these quadratic functions. So if we have 2 real solutions, we're going to have 2 x-intercepts. If you only have 1 real solution, that means that you only have 1 x-intercept, which probably means, or which does mean, that your vertex lies on the x-axis. Then when you have no real solutions, that parabola will not touch the x-axis whatsoever. For example, E, we are given 1/2 x squared is equal to 7x minus 1. And we are finding, again, how many solutions we have. So what we need to do with this is we need to bring over every single term to be on the same side of that equal sign. So we are going to subtract the 7x from each side. This leaves us with 1/2 x squared minus 7x is equal to negative 1. From there, we're going to move the 1 over by adding it to both sides as well. So this leaves us with 1/2 x squared minus 7x plus 1 is equal to 0. Remember, use your discriminant in order to find out how many solutions you have. Our discriminant is b squared minus 4 times a times c. Our a is 1/2. Our b is negative 7. And our c is positive 1. So this is going to give us negative 7 squared minus 4 times 1/2 times 1. The negative 7 squared is 49. The negative 4 times 1/2 is negative 2 times 1 is negative 2. 49 minus 2 is 47. If we compare the 47 to 0, 47 is greater than 0, so we have 2 real solutions. For the next part of our lesson, we are finding the number of x-intercepts of a parabola. By doing this, we're going to be doing the same exact thing as we do when we find the number of solutions for these quadratic formulas. The only difference between those and these is these are equal to y or f of x instead of 0. So what we do is we turn the y or the f of x into 0, and then we use the discriminant again in order to find out how many solutions we have. If we have 2 real solutions, that means that we have 2 x-intercepts. If we have 1 real solution, that means we have 1 x-intercept. And if we have no real solutions, then we have no x-intercepts. So if we look at example A, we're given y is equal to 2x squared plus 3x plus 9. We're going to turn the y into 0. So we have 2x squared plus 3x plus 9 is equal to 0. Our A is 2, our B is 3, and our C is 9. Use your discriminant, so b squared minus 4 times a times c. Plug in your values. We're going to have 3 squared minus 4 times 2 times 9. 3 squared is 9. Negative 4 times 2 is negative 8. Times 9 is negative 72. 9 minus 72 is negative 63. The negative 63 is less than 0, so this would give us no solution, which means we have no x-intercepts. For example B, we're given y is equal to negative x squared plus x minus 6. So again, we're going to turn that y into 0. And we're going to have 0 is equal to negative x squared plus x minus 6. Our a is negative 1. B is 1. C is negative 6. So we're going to use the discriminant. So b squared minus 4 times a times c. Plug in our values. We're going to have 1 squared minus 4 times negative 1 times negative 6. The 1 squared is 1. Negative 4 times 1 is 4. 4 times negative 6 is negative 24. 1 minus 24 gives us negative 23. That negative 23 is less than 0. So again, we have no solution here. So we're going to have no x-intercepts. For example C, we have y is equal to x squared minus x. Again, we're going to rewrite this as that y is turning into 0, so we're just going to have x squared minus x is equal to 0. Our a is 1, our b is negative 1, and our c, we don't have 1, so that's 0. Again, use your discriminant, b squared minus 4 times a times c. This gives us negative 1 squared minus 4 times 1 times 0. Negative 1 squared is 1. Negative 4 times 1 is negative 4 times 0 is just 0. So 1 plus 0 equals 1. 1 is greater than 0. So this gives us 2 solutions. So we have 2 x-intercepts. For example D, we have f of x is equal to x squared plus 12x plus 36. For this one, again, we're going to plug it, or we're going to turn the f of x into 0. So we're going to have 0 is equal to x squared plus 12x plus 36. Our a is 1, b is 12, c is 36. Use your discriminant. Plug these values in. So we're going to have 12 squared minus 4 times 1 times 36. 12 squared is 144. Negative 4 times 1 is negative 4 times 36 is 144. So 144 minus 144 is 0. 0 is equal to 0, so we have one solution here. So that's just one x-intercept. For the next part of our lesson, we're just using any method in order to solve these. So remember, we can solve by factoring, we can solve by graphing, we can solve by using square roots, we can solve by completing the square, and we can solve using the quadratic formula. With example 5a, we're given x squared minus 10x is equal to 1. So with this one, with all of these, you'll realize that I would choose either the factoring method, the square root method, or the quadratic formula method. Only because to me those are the three easiest. For this one, because your C term is on the other side of the equal sign, you would use the completing the square method if you'd like to. However, I'm going to move that 1 over by subtracting it from each side. This leaves me with x squared minus 10x minus 1 is equal to 0. I can ask myself, are there any factors of negative 1 that add up to negative 10? No, there's not. So I'm going to use my quadratic formula. So A is going to be 1, B is negative 10, and C is negative 1. From here, I'm going to plug it into my quadratic formula. So negative B plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. So I'm going to have x is equal to the opposite of negative 10, plus or minus the square root of negative 10 squared minus 4 times 1 times negative 4, all over 2 times 1. This leaves us with a positive 10, plus or minus the square root of 10 squared is 100, minus 4 times 1 is negative 4 times negative 1 is positive 4, all over 2. This simplifies to be x is equal to 10 plus or minus the square root of 104 over 2. That 104, you can divide it by 2 and you get 52. 52 is 2 times 26. 26 is 2 times 13. We're looking for pairs of 2, which you have to choose here. So this just simplifies to be x is equal to 10 plus or minus 2 square root 26 all over 2. You can then simplify this. The 2's become 1's, making the 10 a 5 as well. So it's just x is equal to 5 plus or minus the square root of 26. For example B, we're going to be working with 2x squared minus 13x, minus 24 is equal to 0. You could try to solve this by factoring. If we were to do that, we would have 2 times negative 24, which is negative 48. You want to find the factors of negative 48 that add up to be negative 13, if there are any. You have 1 and 48, 2 and 24, 3 and 16. That 3 and the 16, if the 16 is negative and the 3 is positive, that gives you the negative 13. So we can solve this one by factoring. We would have 2x squared plus 3x minus 16x minus 24 is equal to 0. Because you have 4 terms now, factor by grouping. Factor out an x from the first set of parentheses. Factor out a negative 4 from the second. No, a negative 8. Negative 8 is your greatest common factor between the negative 16x and the negative 24. So this is going to leave us with x times 2x plus 3 minus 8 times 2x plus 3 is equal to 0. From here, you realize that your 2 parentheses are the same, so we can rewrite one of them and then make another with the x minus 8. From here, we're going to set each set of parentheses equal to 0. So we're going to have 2x plus 3 is equal to 0, and x minus 8 is equal to 0. We're going to solve both of these. For the 2x plus 3 is equal to 0, we're going to subtract the 3 from each side. We get 2x is equal to negative 3. Then we divide each side by the 2, and we get that x is equal to negative 3 over 2. For the x minus 8 is equal to 0, add your 8 to both sides, and you just get that x is also equal to 8. So negative 3 over 2 and 8 are our 2 solutions for this one. For our next example, we have x squared plus 8x plus 12 is equal to 0. Again, with this one, I'm going to see if I can factor first. The 12 has factors of 2 and 6 that add up to be 8. So I'm going to factor this out by doing x plus 2 times x plus 6 is equal to 0. From there, I set each of these equal to 0, and I solve. So I'm going to subtract the 2 from each side. We get x is equal to negative 2. We subtract the 6 from each side. We get x is equal to negative 6. So negative 2 and negative 6 are our 2 solutions for this one. For example D, we have x squared plus 11x minus 12 is equal to 0. We're going to use the factoring method for this one also because our 2 factors of negative 12 that add up to positive 11 are negative 1 and positive 12. So this factors out to be x minus 1 times x plus 12 is equal to 0. The x minus 1 gets set equal to 0. The x plus 12 gets set equal to 0. And we solve for both of them. So add your 1 to each side. You get x is equal to positive 1. subtract your 12 from each side, we get x is equal to negative 12. For example, E, we're given 9x squared minus 5 is equal to 4. For this one, because I have an x squared and a constant that we're working with, I'm going to use the square root method. The reason why is because if I move that 5 over to the other side, I can add it. To do that, I get 9x squared is equal to 9. If I divide each side by the 9, we're going to have x squared is equal to 1. And then from here, I can just take the square root of both sides to get that x is equal to plus or minus 1. For example, F, we have 5x squared minus x minus 1 is equal to 0. If I multiplied the 5 times the negative 1, it gives me negative 5. There are no factors of negative 5 that add up to be negative 1, so I'm just going to use my quadratic formula for this one. Our A is 5, B is negative 1, C is negative 1. Use your quadratic formula, which is x is equal to negative b plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. We identified our values, plug them in now. So x is equal to the opposite of negative 1 plus or minus the square root of negative 1 squared minus 4 times 5 times negative 1 all over 2 times 5. Simplify this. We have x is equal to positive 1 plus or minus the square root of 1. The negative 4 times the 5 is negative 20, times 1 is positive 20, all over 2 times 5, which is 10. From here, we have x is equal to 1 plus or minus the square root of 21, all over 10. We cannot simplify this any further, so this is our answer. For our last example, we have x squared is equal to 2x minus 5. I'm going to bring the 2x over by subtracting it from each side. We have x squared minus 2x is equal to negative 5. From here, I'm going to add my 5 to each side, and I have x squared minus 2x plus 5 is equal to 0. My A is 1, B is negative 2, and C is 5. And for this one, I'm just going to use the quadratic formula, so negative b plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. So this is going to give us the opposite of negative 2 plus or minus the square root of negative 2 squared minus 4 times 1 times 5 all over 2 times 1. From here, the opposite of negative 2 is positive 2, plus or minus the square root of negative 2 squared is 4. Negative 4 times 5 is negative 20, all over 2. This simplifies further to be x is equal to 2 plus or minus the square root of negative 16 over 2. We cannot take the square root of a negative, so automatically we have no solution. So anytime you're left with a negative underneath that radical, it's automatically no solution.